In July 1943, a man named Joseph Duckworth flew a single-engine training plane, fabric over a steel frame, one propeller, no radar, straight into a hurricane. Nobody had ever done that on purpose. The eye wall threw the aircraft around like a paper cup. And then, all at once, it stopped. Duckworth came out into a room 20 miles wide. Calm air, blue sky overhead, a white wall of clouds standing all the way around him like the inside of a stadium. He had flown into the middle of something releasing heat at 200 times the entire electrical generating capacity of planet Earth. That is not a storm. That's an engine. Here's the thing nobody tells you about hurricanes. They are not weather that got angry. They are a machine, a very specific, well-understood kind of machine. In 1986, an MIT atmospheric scientist called Kerry Emanuel described a hurricane as a Carnot heat engine, the same idealized cycle as a steam turbine, or the engine in your car.
Every heat engine needs two things: somewhere hot to take heat from, somewhere cold to dump it. A hurricane draws heat off a tropical ocean and exhausts it 12 kilometers up, into air far below freezing. The wider that gap, the more work you get. Emanuel's figure for the tropics is an efficiency of about 1/3.
Which is better than the engine in your car. And once you see the hurricane as an engine, every strange thing about it stops being strange. It's all just plumbing. Start with the fuel. A hurricane needs seawater at 26.5 degrees Celsius, 80 Fahrenheit, and not just at the surface. It needs it warm 50 meters down. A thin, warm skin over cold water, and the storm starves.
And what it burns is not the water. It is the evaporation. When the sea evaporates, it carries an enormous quantity of energy with it, locked up and invisible inside the vapor. Latent heat. That vapor rises, cools, condenses into cloud, and hands every bit of it back to the atmosphere as raw heat.
The ocean turns into sky, and the sky pays it back in fire. Do that across an area the size of Texas, and Noah's arithmetic gives you 5.2 times 10 to the 19 joules per day, almost none of which becomes wind. The winds are the leftovers, about 1/400th. So why does it spin? And, much more interesting, why is there one place on Earth where it essentially can't?
Because the Earth is a spinning sphere, the ground beneath your feet moves faster at the equator than it does near the poles. Anything crossing that surface gets deflected. The Coriolis effect. It is what curls rising air into a spiral instead of letting it collapse straight inward. And at the equator, that deflection is zero.
So a tropical cyclone essentially cannot start within 500 kilometers of the equator. Warm water, humid air, everything else on the list, and no spin to organize it. It has happened once in the entire record. Typhoon Vame, December 2001, 1.4 degrees north. And the same effect is why every hurricane north of the equator turns counterclockwise, and everyone south of it turns clockwise. The storm doesn't choose. The planet chooses for it. Which brings us back to Duckworth's 20-mile room.
The eye is the exhaust stack. Air spirals in, rises violently in the eye wall, and some of it turns over at the top and sinks back down the middle. Sinking air compresses, and compressed air warms. Warm air cannot hold cloud. So the cloud evaporates, and a hole opens in the middle of the worst weather on the planet.
12 kilometers up, the inside of that hole can be 10 degrees warmer than the air just outside it. Seabirds get caught in there and ride it out for days, going wherever it goes. Same engine everywhere, by the way. We just can't agree what to call it. Atlantic and Eastern Pacific, hurricane. Western Pacific, typhoon. Indian Ocean and South Pacific, cyclone. One phenomenon, 3 passports. The naming is even better. In the 1890s, an Australian meteorologist called Clement Wragge began giving storms names, and when the new federal government passed him over for the job he wanted, he started naming them after the politicians he disliked, which meant he could stand at a weather map and announce, entirely professionally, that a large destructive object was wandering aimlessly about the Pacific, causing great distress. And when a storm is bad enough, its name is retired for good. Around 110 Atlantic names, never used again. So how do you switch off an engine like that? You don't. You take away its fuel. Push a hurricane over land and it dies, and NOAA is pointed about why. Not friction. It has been unplugged from the warm ocean that was feeding it.
The stranger death is the one it does to itself. Its winds churn the sea so violently that they drag cold water up from below. Satellites can see the scar afterwards, a trail of chilled ocean, 4 to 6 degrees colder, 200 kilometers wide and 1,000 long. A storm that stalls or loops back over its own track can find it has eaten its own dinner.
But before it goes, it does the damage. And here almost everyone's intuition is wrong. It isn't the wind. The engine's rotating winds pile the ocean itself into a mound and shove it ashore. Storm surge. Across 50 years of American hurricanes, surge accounts for about half of all direct deaths. Wind, fewer than 1 in 10. The 1970 Bola cyclone killed between 300,000 and 500,000 people in what is now Bangladesh. And it killed them with water. Which leaves one genuinely open question.
If this engine's whole job is to lift heat off the ocean and throw it upward, is it doing something for the planet? Emmanuel proposed in 2001 that tropical cyclones might be a real part of how the oceans move heat out of the tropics. In 2007, Shriver and Huber found observational support written in those cold scars. But newer models push back. Most of that heat seems to return to the atmosphere within the same season. The honest answer is that we do not yet know how much it matters.
I rather like that we don't know, because the part we do know is stranger anyway. A hurricane isn't the weather losing its temper. It is warm water, cold sky, and a spinning planet assembling themselves, with no instructions and nobody's permission, into a working engine the size of a country. One that runs at about 1/3 efficiency and refuses to start on the equator. Every summer, the ocean builds one. That one came ashore in Nova Scotia in September 2019. It had already left the warm water behind, already dying. It still took the trees down. And in 1943, a man in a training plane flew into the middle of one and found sunshine. If that's the sort of thing you'd like handed to you once a week, subscribe. I'll be here. Newt will be under the desk.